Good morning, ma'am. Myself Alpana Tukaram Pattekar. My ESN is 51. Today I am going to tell you about understanding quality attributes. Understanding quality attributes. Under this heading, we will study functionality and architecture, architecture and quality attributes, system quality attributes. Under system quality attribute scenarios, availability scenarios. Means under this module we are focusing on the different quality attributes. That is, when we consider a software, that is, attributes of good software are nothing but availability. Availability is the software should be available all the time, and how the design is built, design decision, this is the availability. Interoperability, how the software communicates with other devices and peripheral model, etc. Next is modifiability. When new technology comes or demand from the stakeholders come, then we need to change the software, that is modifiability. Also, performance means how it performs, whether it is satisfies all the user requirements or not. Security means to keep the software secure, and testing. Once the software is built, we can test its correctness, that is testability. And next is usability, should be user friendly. These are the different requirements that one should know before building the software. Now the first topic we see, that is functionality and architecture. Functionality and architecture is how do you define the functionality? Means it is the ability of the system to do work for which it was intended. A task requires that many of the system elements work in coordinated manner to complete the job. The analogy for this task requires that many or most of the elements work in a coordinated manner to complete the job. For example, just as a farmers, electricians, plumbers, drywall hangers, painters, and carpenters all come together to cooperatively build the house. Means all of these people will play their own role in order to construct the house, to build the house. In this way, the functionality with respect to a software architecture, as we know, the software architecture is a structure of structure. Means it is the combination of many finite modules, and each module exhibits its own functionality, so that ultimately the end task can be fulfilled. And next, software architecture, it constrains its allocation to structure when other quality attributes are important. This is what the functionality, that is ability of the system to do work for which it was intended. Next we see the architecture and quality attributes. Architecture and quality attributes are how the architecture is built in order to fulfill the quality attributes. That is, achieving quality attributes must be considered throughout the design, implementation, and deployment. No quality attribute is entirely dependent on design, nor it is entirely dependent on implementation or deployment. Achieving a high quality attributes must be considered throughout design, how to implement it in a real system on a machine and the deployment, that is making available the software for use. And no quality attributes are entirely dependent on design, nor it is entirely dependent on implementation nor deployment. Means quality attributes is one phenomena. All these different aspects, that is design as well as implementation, the software as well as deployment, all three aspects come together that provide a quality attribute, but individually they will not support for the quality attributes. For example, usability involves both architectural and non-architectural aspects. Some aspects will come under architecture and some will come under non-architecture aspect. That is, architecture is a physical model and logical model. Here the non-architecture is a phenomenon, that is qualities of good attributes, qualities of a good attributes. Next, modifiability is determined by how functionality is divided architectural and by coding techniques within a module. Non-architectural. In case of non-architectural, by coding technique it is divided. In case of architectural, dividing functionality means when we divide the functionality and when the aspects of modifiability comes, then no need to change the entire module. Anyhow, the functionality has been divided on which function has to be changed future in future. Next, we see the performance. Performance involves both architectural and non-architectural dependencies. The message of this section is twofold. Is in twofold. Performance of any software architecture, it depends on both architectural and as well as non-architectural, and this message of this section will represent different meaning here. Meaning, architecture is first point. Architecture is a critical to the realization of many qualities of interest in a system, and these qualities should be designed in and can be evaluated at the architectural level. Architecture by itself is unable to achieve qualities. It provides the foundation for achieving quality attributes. The first point is the architecture is critical. When you design a software architecture, you need to take care of many aspects, that is different architecture styles, their behavior, the attributes, the dependencies, and also independencies. Apart from this, architecture by itself is unable to achieve the qualities, so there are different aspects support that are supporting to achieve the qualities, and it provides a foundation for achieving the quality. This is about architectural and quality attributes. Next, we see the system quality attributes. Under system quality attributes, first is quality attribute scenario. Quality attribute scenario is a quality attribute specific requirement. It consists of 6 parts. That is, first one is source of stimulus, second is stimulus, third is environment, fourth is artifact, fifth is response, and sixth is response measure. Let's we see the source of stimulus. Source of stimulus. This is some entity that generates the stimulus. This is some entity that is entity in the software with the real-time object. The existence of one does not depend on the others. That is entity here. It is the some entity. It may be a human entity, or it may be a computer system entity, or any other actuator that generates the stimulus. Stimulus means that is an entity, and when you imagine the term, that is quality attribute stimulus is a part of that entity, and next we see part of that entity. Next we see the stimulus. The stimulus is a condition that needs to be considered when it arrives at the system. That means stimulus means that is the condition that needs to be considered when it arrives in the system. Stimulus, the object may be in stimulus the object may be a human computer, or any other actuator at the time that used during beginning of the object. You use this system that is called as arrival time. The time that used during beginning of the object is used in beginning of the object used in the system, that is called arrival time. Here this is called a stimulus. Next we move to the environment. Is the stimulus occurs within certain conditions. The system may be in an overload condition, or may be running when the stimulus occurs, or some other condition may be true. In the environment, the stimulus occurs in a certain condition, that is object will be presenting a certain conditions, or the system may be in a overloaded condition, or running when stimulus occurs. In the environment, there are three types are being discussed here. That is a overloaded condition, if the system is overloaded, and it may be running when stimulus occurs. When the system is in a process, the stimulus that the object is presented or some other condition may that can be applied when it may be true. Other condition may be applied when it is true. Next is artifact. Artifact is some artifact is stimulated. This may be the whole system or some piece of the system. Artifact means it is the sometimes you can consider it as a whole system, or sometimes it may be a part of or piece of the system. Next is response. The response is the activity undertaken after the arrival of the stimulus. Response means that is when we write a program using some object, whether it is a software object or some logical object or a physical object. When it arrives, we make a call to that particular object using a different system calls. Then that particular activity undertaken after arrival, it is called as response of a stimulus. And last one is response measure. Response measure. When the response occurs, it should be measurable in some fashion so that the requirement can be tested. Response measure means we can say how do you measure whether the response provided by different entities physical or logical, maybe physical or logical, whether it is appropriate or not, and that is a response measure. When the response occurs, it should be measurable in some fashion so that requirement can be tested. This figure shows the parts of quality attribute scenario, that is source of stimulus. It is the source of stimulus. It is the source of stimulus. It is a physical object here, that is a woman, and it is interacting with the system here. And now this source of stimulus, the action took by this particular woman or a person, it is a stimulus. It is a stimulus. And artifact means nothing but the artifact means nothing but the time, nothing but the part of the system. It is some piece of the system, and this is actually the environment, also actually called as environment, where the stimulus has been operated. And next, what is the response provided by the particular artifact. What is the response provided by the particular artifact, that is measured using response measure, whether it is 1 or 2 or 3 or 4, etc. You can measure it using the different graphs like pie graphs or chart, or using different system techniques. This is how we can measure the response measure. And this is the picture that represents how the quality attribute scenario would produce the software architecture. Next is under system quality attributes, we see next availability scenario. An availability scenario is concerned with system failure, and associated consequences. Failure are usually a result of system errors that are derived from faults in the system. It is typically defined as availability equal to alpha. Alpha is represented as mean availability is represented as alpha equal to mean time to failure divided by mean time to failure plus mean time to repair. We can define the availability with the equation, that is availability that is represented as alpha equal to equation, that is mean time to failure divided by mean time to failure plus mean time to repair. Means when you define or when you construct a particular system, it may be represented with all kinds of internal tests. Then also sometimes there may be faults. Faults in general we can call it as a system errors, and due to this kind of faults we cannot get the system represented successfully. Means the system will fail sometimes, and this failure, instead of representing in the form of sentence, we can represent it in the form of equation, that is availability, that equal to the equation where availability equal to alpha equal to mean time to failure divided by mean time to failure plus mean time to repair. Means the average mean time when the system is failed, that is divided by mean time to failure and mean time to repair. How much time it was taken to repair to present as a successful to perform its intended task successfully. Next is source of stimulus under availability scenario. Source of stimulus is we differentiate it between internal and external indications of faults and failures, since the desired system response may be different. In our example, the unexpected message arrives from outside the system. Source of stimulus means that is to differentiate between both the internal and external indications of faults or failures, because that is unintentionally some messages arrives out from outside the system. Apart from that, checking for fault and tolerance, sometimes the unexpected message will come. This is called as source of stimulus. Source of stimulus. Next, we move to the stimulus. Stimulus is a fault of one of the following classes occurs. Means that is the stimulus may occur in the omission, crash, timing, and response. Let us see what is omission. Omission: a component fails to respond to an input. Omission means a component fails to respond to an input. Means omission means when a component of the software architecture it may fail to respond to a input. For example, in the Google search engine, the Google search engine or Google browser, when we enter some notes name that I want to download, then it will not get an appropriate result. It will we want to download the notes but some video files I am getting, but I want the PDF actually, so it was response, so the response is wrong. So this type of response that provides the wrong inputs is called omission. That is omission means component fails to respond to the input. Next is crash. The crash is the component repeatedly suffers omission faults. The crash is when the component is repeatedly suffers omission faults, that is when multiple times failure comes, that is responding to the input in some other way, that is not a way to represent. In that case is called the omission, and multiple operation of this omission is called as crash. Therefore, crash is a component that repeatedly suffers from omission faults is known as crash. Next is we see the timing. Timing means a component responds but the response is early or late. The timing means this is whether the component that may respond on time or sometimes after the half an hour or maybe after 1 hour or maybe 1 day or 2 day or maybe take more days, weeks, like so on. This is called as timing. Next is the response. Response means a component responds with an incorrect value. The response means response with an incorrect value. Then also a system is not available. This is called as availability scenario. In availability scenario, the first important factor is the component fails to respond to an input. Then also it is not available to the user. Next, the component repeatedly suffers fault omission fault means multiple times the same error comes for proper input. It is not providing the proper output. Then it is called as a crash timing means when I am requesting for the data it may respond lately. This is called as timing. Now the response means the component responds with the incorrect value, then also the system is not available. In all these four conditions the system is not available. For all these conditions, all these four conditions makes system unavailable. This is the availability scenario. There is a more availability of the factors that make the system available. And the diagram shown below explains the availability scenario. Source may be internal source may be internal and external source may be person or a computer or maybe any other actuator. And next is stimulus that is provided by the source to the artifact, which is also known as environment, totally known as actually known as environment. That artifact provides a response that is measured in the response measure using the graphs, etc. Stimulus may have stimulus CC is the fault that makes the system unavailability is omission, crash, timing, and response. This is the stimulus, and next one is artifact. It is the process, storage, processor, and communication. Next is environment. An environment can be normal, degraded, operational, and next response provided by artifact may be record, notify, disable, continue, normal or degraded, be unavailable. Means when particular system is being using, it has to available or available all the time. Means in one line we can say the system must be available all the time. When the user or the stakeholder require it and they can use it. When it is not available, in that cases we get this kind of faults, that is omission, crash, timing, and response in stimulus. And in response measure, that it can be measured in using graphs like pie charts, etc. That we can see repair time, availability, available, degraded, and time interval. This is the end of my seminar representation. Thank you, one and all.